Okay, let's go, Bruce. Okay, everybody. We've got Bruce Clank from Dell Technologies talking about what's new in mainframe PowerMax.
Thanks, Brett. Good afternoon, good evening, good morning, depending on where you're joining us from. Thanks for coming
Yeah.
today. As Brett said, want to talk to you about PowerMax storage for mainframe. Happy to take questions as we go. Um, we have many enterprise customers, mainframe customers that rely on PowerMax to deliver its always on data availability, to be able to easily manage rapid data growth, ensure predictable performance, and meet your demanding SLAs, as well as reducing the total cost of ownership. And you'll see, particularly with the new generation, there's been a lot of additional focus on the total cost of ownership and things like the environmentals, given what our customers have been asking us to do. For all of you with mainframe, we know that downtime is really not an option, and downtime can lead to financial penalties, regulatory action, or in some extreme cases, even potentially loss of life, not to mention the inconvenience caused to your customers. For example, if your e-commerce or financial trading site went down, that could again lead to not only lost business, but potential fines and regulatory action. If a doctor was unable to perform a surgery because patient data was unavailable, that could have very serious consequences for both the patient and the hospital. Dell has a really comprehensive offering for mainframe in the form of the PowerMax 2500, 8500, which are the latest generation, as well as the 8000 for DASD storage, and our DLM product for virtual tape, Connectrix for SAN, and all potentially automated by our GDDR product. Our commitment to mainframe is absolutely we continue to provide innovative solutions, reduce the total cost of ownership, and simplify and automate the mainframe storage world. Again, we really, our mainframe solution consists of really the four main components: the disk, the PowerMax 2500, 8500, and 8000 arrays, featuring state-of-the-art NVMe storage, and really supporting mainframe from its inception. And we're going to go into more detail on these in the upcoming slides. And DLM, which virtualizes really outdated physical tape technology and reducing the costs and dramatically increasing performance. GDDR can monitor, provide alerts, and automate the recovery of the entire mainframe environment, not only the disk and tape environment. And the Connectrix SAN provides best-in-class switches for networking of your mainframe environment altogether. We have many customers who have mixed mainframe and open PowerMaxes, and this has been, again, fully supported on day one. With the increased pressure we see on your IT staff and some mainframe retirements, we've also seen an increased focus on environmentals, power, cooling, and floor space, and that's driving an increased interest from customers in consolidating their open systems and mainframe environments in many cases for ease of management, and again reducing the total cost of ownership, particularly for some of the kind of small to medium-sized mainframe customers, where again they might have a larger open systems environment, and relatively small, because mainframes are so efficient, smaller mainframe footprint, and they can really consolidate on the PowerMaxes and reduce the management and environmental costs. What I'd like to cover more in depth with you today is to introduce the latest generation of PowerMax, the PowerMax 2500 and 8500, and take you through the new architecture and some of the highlights behind that and why it's such a major step forward. Give you a platform and packaging overview, talk about some of the efficiencies built into the overall microcode, talk about some of the enhancements we've made around sustainability, security, and zero trust, and then tie in our specific mainframe innovation and new capabilities around Z synergy. So let's dive into the overall platform interview. Here's a summary of the two new models with some of the mainframe specific details all in one place. We'll get more into the details of this coming up, but wanted to give you a quick overview. The PowerMax 2500 is a 2 to 4 node array. If you're familiar with the prior VMAXs and PowerMaxs, we used to refer to these as the engines. Now we refer to them as nodes and node pairs. So up to 4 nodes, or what would have been the equivalent of two engines. Dramatic increase in the amount of capacity that we can support, up to 3.8 petabytes of CKD capacity. But still knowing again that that many mainframe capacities are not very large compared to open systems, we kept a nice small potential starting size of 15 terabytes. The 2500 can support up to 64 ports, a combination of FICON, fiber channel, and iSCSI ports. The 8500 can support up to 16 nodes with up to 10 petabytes of capacity. Again, the same 15 terabyte starting size, and up to 256 ports, a combination of FICON, fiber channel, and iSCSI. Both arrays are fully support CKD compression of the data, and we'll get more into that in detail. Really, industry first for CKD data. And we have the 32 gigabyte FICON exploitation to be compatible with the IBM Z16. We also introduced with the 2500 and 8500 support for Z hyperlink reads, and we've simplified the software offering and really have one inclusive software set that comes with every 2500 and 8500, our innovative and very space efficient snap technology, the full flash copy compatibility, the compression for CKD data, as I mentioned, our auto swap capabilities, ZDP, which we'll get into in more detail, data at rest encryption, the management suite of Unisphere and Cloud IQ, and obviously the key IBM connectivity and support technologies, things like high performance FICON, parallel access volumes, and our PAB optimizer unique mainframe capabilities. If you do opt for remote replication, that is an a la carte title, the SRDF, all variants, as well as the GDDR automation I mentioned earlier, and resiliency. Mentioned the two PowerMax models. The 2500 gives you a very modular, dense entry point, 2 nodes with 4 petabytes in a very space efficient 5 rack units. And then the 8500 with up to the 16 nodes and 10 petabytes in a single system. And as we'll get into in a minute, the architecture allows you to really independently scale the compute and front-end nodes very independently. So again, getting into the new dynamic fabric architecture, this is a nice marketing graphic that shows, but really demonstrates that you can now completely dynamically and independently scale your front end nodes, independent from what we're now calling the dynamic media enclosures, where the actual drives, where the actual storage drives are. So in the past, you tended to upgrade in tied together the engine and the dynamic media enclosures. Now you can completely independently do that, which works very well for mainframe customers. A lot of times you need more front-end connectivity. You don't need as many drive slots given the smaller capacities. So you no longer you need to add the dynamic media enclosures for drive slots if those are not needed. And now every front-end node has complete connectivity to all the drives within the system. give me a little more detail on the packaging. When we look at our mainframe customers, most of them can now fit in even the largest customers can fit into a single rack which would have up to 12 nodes. Um, and you see in the middle, the dynamic fabric to support the connectivity between the nodes and the DMEs, and up to 4 dynamic media enclosures. Each dynamic media enclosure can have up to 48 drives, in each one being 2 rack units, to support up to 192 drives per rack. Again, we've also simplified how we do the I/O modules. You now no longer need dedicated FICON I/O modules. You have a single module that can support fiber channel, FICON, and our SRDF for replication technology. We also offer a 25 gig for iSCSI file and SRDF if you want to use iSCSI instead. We have a dramatic increase in the amount of global memory available, which again helps support the much larger backend capacities supported per node, and a new technology called flexible RAID, which we'll get into in more details. If you do need even larger, even a larger system up to potentially the 16 nodes of the 8500, we would support that in 2 racks and show a more balanced set of nodes across the 2 racks, as you can see here. And now going up to 8 dynamic media enclosures, so that's 384 drives in the 2 across the 2 racks. The 2500 introduces some other interesting potential capabilities in that this again very space efficient single node, single DME, all in 3 rack units, and you can potentially add again the second node pair, nodes 3 and 4, and the second DME. So that's 4 nodes in 10 rack units. And what we've seen some customers and some service providers interested in is being able to have 3 independent systems in a single rack. So these are 3 uniquely separate PowerMaxes, but all able to fit in a single rack for very dense configuration, and again saving on the power for spacing and cooling needed. What's in each of those PowerMax nodes for the 2500 and 8500? The 2500 uses a Cascade Lake 2.8 gigahertz processor, Intel processors, 32 cores per node, and again up to the 16 front-end ports per node. The 8500 uses a slightly faster Cascade Lake Intel 3.9 gigahertz processor with up to 36 cores per node, and again the same 16 front-end ports per node. The dynamic media enclosures are different than the prior generation. These are support now 48 dual-ported NVMe drive slots per dynamic media enclosure, supporting a range of capacities going from 3.84 terabytes up to 30 terabytes. For most mainframe configurations, we see they tend to be more in the 3.84, 7.68 size. There's not a lot of cost savings by going to larger drives with flash drives. There's fully redundant power, the 1+3 redundant power across this, and all of the components are hot swappable. For a long time, we also continue to support the true non-disruptive upgrades. This has been a key capability for VMAX and PowerMax for generations now. There's no rolling outage required to upgrade the microcode, no failover, failback, no switching in terms of the front end if you're open systems on the lone ownership. And so really you can do microcode upgrades in under 6 seconds across the entire array with zero component downtime. This is customers have really liked this capability and the fact they don't have to kind of schedule an outage to do a code upgrade. We continue to offer very flexible deployment. You can, if you need to go to that second cabinet for say an 8500, those can be up to 25 meters apart in any direction. We fully support things like a hot aisle, cold aisle cooling, overhead cabling options, and a number of third-party racking options. We have had customers put PowerMax 8000 inside the Z14 ZR1 that has the 16U free space in it, as well as like a Linux Rockhopper 2 LR1. And we're also excited to be able to support the latest Z16 A02 AGZ rack mount processor and co-locate that in a third-party rack. Next, I want to talk some about some of the flexible RAID technology. Again, this is new with the 2500 and 8500. We now can balance the RAID groups across all available nodes in the system, and this provides a reduced RAID overhead. And really, instead of having dedicated spare drives, we now have really universal spare space that's carved into each of the drives. We can now support really single drive upgrades and far more capacity options. So really the RAID group is not tied to a specific number of drives. It really spans the drives in the system. And this also is in anticipation of ever larger flash drives coming. We're already at 30 terabytes, but we know even larger ones are coming from the drive vendors. And one of the concerns obviously would be on the rebuild times as these drives get larger and larger. If you have to replace a drive and the amount of time to do the rebuild. So this flexible RAID technology offers dramatically faster rebuild times as well. Here's an example of, again, some of the advantage of the flexible RAID technology from your perspective in terms of upgrades, rather than having to do the much more larger steps, as the darker blue bars here show. If you needed to do an upgrade, you needed to add an entire new RAID group of drives, whereas now, particularly for mainframe customers, we don't see that there's usually dramatic growth of capacity. You can do a much more granular increase in capacity if that's all that's needed. So you can add that single drive, and all of it will be added to the flexible RAID group, and you can have these much more granular steps of increases in capacity than when you had to add an entire RAID group of drives. Part of the increase in efficiency is our increased global memory resources that we have available to us. So we have a lot more in the DRAM and what we're calling persistent memory, that increases the amount of user cache available to you, as well as the system cache that's available for the system. There's been, in addition to having more global memory available, we're making more efficient use of the global memory with flexible metadata pooling to optimize the cache resources. We again have more effective capacity, up to 2 petabytes with the 2 nodes, and up to 10 petabytes with the 16 nodes. We're also able to leverage the compression, the data reduction, which is guaranteed at 3:1 for all CKD data that's not host compressed or encrypted before it gets to the array. So any data that comes to us that's not host compressed or encrypted, we'll guarantee we can reduce at least 3:1. And if we don't meet that, we'll provide additional capacity at no charge to you. And this additional global memory also allows us to support up to 65 million snapshots to improve the RTO and RPO against failures, outages, and hackers, as we'll get into around our cyber recovery solutions. We offer on the 2500 and 8500 up to 4 different memory configurations. You don't really need to worry too much about the specifics here, but just we will size your system working with your account team to be most efficient possible and most cost effective possible based on your capacity and performance needs and expected kind of growth requirements. But we, again, will tailor the system both from a capacity perspective as well as a cost perspective to meet your needs. I mentioned earlier, there's been increased focus across the industry on sustainability, and this is another area. You've seen some of it in terms of some of the space efficiency, but want to also talk about some of the improvements we've been making around power efficiency. The 2500 and 8500 are dramatically more efficient than the prior generation, due in part to efficiencies in the amount of storage that can be supported behind each of those nodes now, but also due to obviously efficiencies in the latest generations of hardware. We also introduced in the fall a new intelligent power distribution unit that's available both, again, as a standard option on the 2500 and 8500 that provides real-time information and monitoring of the power, voltage, current, frequency, as well as external temperature and humidity of the PowerMax and the components in the rack. It tracks the total power consumption for all those components and provides remote management via a secure IP of up to 108 of the power connections across 2 racks. It's a modular design, and the reporting and analytics is available via SNMP and Redfish APIs, and that can be used to set threshold alerts and generate insightful reports based on the power usage, the environmental conditions, and carbon footprint changes over time. Here's an example of the dashboard that's available to you. You can see the real-time power input in kilowatts and the percent of the total rated capacity. You can see the 3-phase or single-phase input voltage and current, and then the real-time temperature and humidity. I mentioned earlier the ability to co-locate the PowerMaxes within the IBM Z, depending on your IBM Z option. Here's a picture of one of the customers that put a PowerMax 8000 inside the Z14 ZR1. And we don't have a customer example yet of this, but I just did a pictorial view of what could be done. The Z16 A02 AGZ is the rack, third-party rack-mounted Z16. There are a number of different Z16 configurations available, so it will depend on which Z16 rack option and which, how large a Z16 A02 you have, how this would work and how it would look. But I took one example which would start at about 18 rack units, and then you could put either a 2500 or 8500 in the same rack, because both of those would start at only 5 rack units, or an 8000 at 12 rack units. One of the other major areas of increased interest, and I'm sure you're hearing it here at GSE and in past GSEs, is focused on increased security and support for to protect against cyber intrusions. Really, when we look across the storage and PowerMax, we want to make it the world's most secure platform and really deliver a zero trust infrastructure. So this would be across both storage security, things like data rest encryption and built-in hardware security, and we'll talk more about that in a minute. There's host app security, and that would really focused on things like virtual and physical air gaps, and our secure snaps with very granular RPOs, some advanced threat detection. We've got a couple of things we'll talk specifically about there, and some new capabilities we're offering. And then obviously having admin security and controls, things like being STIG hardened and FIP certified, as well as meeting common criteria, and things like multi-factor authentication. So let's dive a little bit deeper into the actual storage security part of it. I mentioned, well, before I go there, the data rest encryption on the PowerMax 2500, 8500. There are a few changes from the prior generation. In both the current and the prior, we fully supported both internal and external key managers. But what's new with the 2500, 8500 is the ability to also do key rotation for data at rest encryption. This is something some customers and their auditors have asked for, and we're pleased to be able to offer the ability to now do key rotation within the data rest encryption. Also, a change is in the past. We did the encryption in the actual nodes or engines. Now we're using fully self-encrypting media for the encryption. But now let me talk a little bit more about the built-in hardware security parts of it. This utilizes what we call the trusted platform module hardware that's actually verifying the hardware components, and also takes advantage of Silicon root of trust features in Intel's Cascade Lake system to verify the identity of system hardware components to prevent malicious activity. So we're in the factory. When the PowerMaxes are built, we're embedding immutable components with keys fused into the memory by Dell manufacturing. So if any of the hardware is tampered with or modified after it leaves the factory, that would be detected when the array is powered up. We also have the secure boot chain of trust, which really extends the firmware chain of trust against any malicious software being introduced into the array, and again uses a cryptographic authentication for any subsequent firmware loads. So when you get new firmware, you can also be assured that that has also not been tampered with. We introduced with the 2500, 8500 a new version of the Unisphere management suite. And one of the, again, on the security aspect, we introduced multi-factor authentication. So you can add that extra level of security around who has access to the management console with RSA Secure ID. And we're expanding that to other secure ID vendors, and would be welcome your feedback. You may be familiar with the IBM Z Security and Compliance Dashboard, and our CyberSec IQ dashboard in Cloud IQ has a similar goal, but focused on the storage. So Cloud IQ provides really intelligent infrastructure insights into PowerMax resources by leveraging machine learning to help users reduce the risk, plan ahead, and improve productivity by helping you answer questions about your data center to enable the optimal health of your environment. So it's really looking across the entire storage system and really monitoring overall activity. Cloud IQ will make it faster and easier for you to analyze and identify issues. And the cybersecurity is a new feature within Cloud IQ that identifies potential security violations. So the system configurations are continuously monitored against rules that you have set up that you know what security configurations does your particular environment require? Do you, for example, expect all arrays to have data rest encryption turned on? So if a new array were to come in and, by mistake, the data rest encryption was not enabled, that would get flagged in the cyber security IQ capability. But we'll get more into some of the specifics we're able to leverage, particularly now that we have the ability to do data reduction on CKD data for cybersecurity and some enhancements in that area. Given all the customer and industry attention on cyber, I think most of you are probably familiar with the NIST cybersecurity framework. We've been historically been strong in the protect and recover areas of the NIST framework with our space-efficient SnapVX technology, ZDP, and our ZDP two-actor security, which we'll talk about. What customers have been asking for now is, can we help them detect when they're being attacked, give them some sort of warning, send up a flare. This is an important area to our customers, and we are responding. And you recall with the introduction of the 2500 and 8500, we have the what we're calling data entropy based anomaly detection, which I'll cover in a minute, where again, now that we can do data reduction on CKD data, we can look for changes in the amount of reducible data. And that's now in beta on CloudIQ, and I've got a couple of screenshots of that coming up. We're happy to now also introduce, in this past fall, we introduced a new capability around anomaly detection we're calling cyber intrusion for Z systems, or ZCID, which we'll talk more about in a minute. And there's also some other projects underway to look at some access pattern detection as yet another way to detect potential anomalies and cybersecurity threats. We've also been working with Rocket Software, who makes many of the IBM data utilities, including DB2 utilities, and they've announced the Rocket Data Recovery for Dell ZDP that enables recovery of specific data sets from ZDP snapsets. We'll have more about that coming up, and I'm sure John Krosno, who presented here earlier today, would be happy to discuss in more details with you the Rocket capabilities and how they can leverage ZDP. And really, again, it can really help you find the critical data sets from ZDP snapshots, help you surgically restore the data relevant to application recovery, and reduce the recovery point objective from up to 24-hour-old data to down to 5 minutes. So I kind of jumped ahead. If you're not familiar with PowerMax and some of the capabilities we've offered, I've talked about a few things you may not have heard of, so let's take a step back. If there was ever sort of a killer app for mainframe, we believe our ZDP is it. We actually introduced this in 2016, the data protector for Z systems, and it really provides a unique solution that helps you protect the mainframe environment from data corruption, including really an industry-first mainframe interface to take advantage of our native SnapVX logical snapshot capability. With the scale to support snapshots of up to 32,000 volumes every 5 minutes, and provide up to 256 versions with virtually zero impact to the system, ZDP provides a highly granular protection for user errors, as well as for malware attacks and any other logical data risks that might threaten the mainframe. In addition, the user experience is tightly integrated to our standard mainframe management, reporting, and security model, and this is unique functionality to Dell. What many of our customers have been doing with ZDP and our SnapVX solutions over the last 8 years is supporting, again, up to that 1,024 snapshots, and the snapshots can be either immutable or secure or non-secure or a mixture of both. And what we typically see is the mixture of both. The interval between snapshots can be minutes apart, which allows selection of a snapshot with minimal data loss from the time of the corruption, or just an accidental update or change to some data, or a potentially malicious attack. Snap VX was introduced actually in 2014, and again ZDP in 2016. So we've been working with customers for many years now, and further enhancing our support. And next, I'll talk about one of the newest enhancements we've made to ZDP to help further ensure you have a cyber resilient environment. So we've had customers say, ZDP is great, and I can take these snaps, and I can set up my environment to make sure I have these very granular point-in-time recovery points. But what about the potential risk of someone actually altering my environment, my protection environment? And I think that really came to light in one of the earliest kind of very publicized hacks, the Sony hack, where somebody had gotten into the system, long before, and really deleted all their backups. So they really had nothing to recover from. And again, you're doing your diligence, and you set up a great environment to take these snaps. But what if someone were to alter what ZDP is doing without your being aware of it, and basically disable it? So we created what we call ZDP two-actor security, which will require two different people with separate credentials to be able to create and modify the execution of ZDP. So they have separate roles in the setup and execution of ZDP, which helps ensure that if a single employee were trying to destroy the protection, they can't act alone. This is completely optional on your part, but it is something similar to things like data rest encryption and our secure snaps that no employee on their own could change or could turn off. Once you've implemented two-actor security, or told us you want two-actor security implemented, nobody within your organization could disable it. You'd have to contact Dell, and we could then disable it if you decided to. I mentioned earlier with the 2500 and 8500 and the fact of our built-in CKD compression, we can further provide ways to detect potentially malicious activity and take corrective action to prevent hacking or minimize the potential corruption. And so what we're doing is we're going to measure the size of the verified data at the volume level and get the data reduction ratio. How reducible is the data that we're seeing, and over time? So what's sort of normal behavior, normal amount of reducibility of that data that we're seeing in the PowerMax? And if we see a significant change in the amount of unreducible data, as indicated here, between, say, 10 minutes and 15 minutes, when going from 15 gigabytes of unreducible to 65, that would indicate maybe a potential ransomware attack is occurring. Someone's gotten into the system and turned on maybe host encryption, and is going to be encrypting all the data that's on the array, and going to be asking you to pay ransomware to get the keys and unlock the data. So we would detect that. As I mentioned earlier, now that will also be available to be reported to you on our Cloud IQ cybersecurity page. And again, this is, you might be familiar with the Z Security and Compliance Dashboard, but now we again will have this capability to flag if there's a spike in the unreducible data in the CyberSec IQ and dashboard within Cloud IQ. Another mainframe industry first from Dell is our introduction of the Z cyber intrusion detection, ZCID, which enables this continuous monitoring and inspection of the access rate of data selected. So as we look at anomaly detection, there's really several different methods that can be used to watch for potential anomalies and ways of doing detection. And so we want to continue to broaden our abilities for you to detect potential anomalies and alert you to those. So in this case, we're looking at the access rate of data selected based on some rules that will help you set up and alert and trigger actions to be taken if a limit set by the rules is exceeded. So the intent is to use ZCID in concert with SnapDX and ZDP to ensure that if you have an intrusion or data corruption, if it's suspected that data is being snapshotted and therefore protected, can be easily recovered by comparing the ZCID anomaly timestamps and ZDP and ZDP snapshot timestamps to recover using a snapshot taken just prior to the intrusion event. So the rationale for offering this feature is that cyber attacks, viruses, and silent malicious programs could insert themselves into the array and begin to manipulate or access data over time in patterns that are atypical of the monitored and what we've learned over time as kind of normal behavior and normal mainframe data access patterns. So knowledge of this activity can be extremely powerful for helping to identify attacks, corruption events, and therefore becomes another tool to help you protect your data. So ZCID will collect really at a data set volume or group level, SMS group level, what the normal access rates are over time. And if we see these rates vary by a user specifiable amount, we'll issue warning messages to the ZOS console detailing which volumes of data sets are experiencing that abnormal access rate. We'll compare again to user specified exceptions and issue the warning messages. You can also define different analysis windows. So if you're, you have obviously things like kind of your weekly accesses, and those could exhibit different behaviors, different kind of access rates than say end of quarter or end of year accesses. So you can set up those different analysis windows to reduce the potential of false positives. We've talked about the data at rest encryption. Again, I think the overwhelming majority of mainframe customers opt for our data at rest encryption. It's fully supported as a default option in all PowerMax 2500s, 8500s, and 8000s. Encrypts all the data, is fully FIPS validated, supports a 256 AES 256 encryption, and again now uses the self-encrypting drives. We support the external key managers, including IBM, GKLM, and the Thales Cipher Trust. And as I mentioned, we now also support the ability to do key rotation. We've talked about some of the CKD compression as well, but just again, on the 2500 and 8500, we're able to do what we're calling activity-based compression for CKD volumes. So this, again, helps you further reduce your storage costs. You need less physical capacity, fewer actual flash drives on the back end to support the amount of front end capacity you need, and all CKD data types are supported, so there's no restrictions, no limits on the CKD data that can be compressed, and this is fully controllable by you by symmetric storage group. So by default, it's enabled, but you can opt to disable the compression on any storage group if you choose to. We provide new reporting within Unisphere of the data reduction as well as in the mainframe enabler. I'm showing a Unisphere screen here. We're again the first all-flash array to offer compression for mainframe data, and again that 3-to-1 compression guarantee, data reduction guarantee on CKD data that's not host encrypted or compressed. There's really zero to minimal performance impact. Again, what we're doing is using our intelligent algorithms to say if the data is very active, it will not be compressed when it's obviously in the PowerMax cache. It only gets compressed on when it goes to the actual backend, and you need actual backend storage resources. And we have some simplified reporting and trending, so you can easily identify reducible versus non-reducible data and help plan for your capacity growth. With Unisphere 10.1 in the fall release this past fall, we introduced a new Unisphere mainframe dashboard that provides much more kind of mainframe specific information in things more, what a mainframe storage administrator is comfortable doing, but in a Unisphere GUI dashboard. Again, we're seeing more customers interested in training new mainframe experts, mainframe storage administrators coming in to replace those that are getting ready to retire potentially, as well as more customers looking to consolidate mainframe and open systems on a single PowerMax. And you want the ability to, again, put the information in context. So we have open systems dashboards and now mainframe dashboards. Another nice enhancement we introduced with this is some additional reporting both for open systems and mainframe for our SRDF information, showing you the complete SRDF topology and being able to drill into the particular status of the replication and get additional details on your remote replication. Some of the new capabilities with the 2500, 8500 around our IBM Z Synergy support is the introduction of Z Hyperlink support. This is Z Hyperlink reads, similar to how IBM introduced Z Hyperlink. It's, again, a new low latency interface between the Z and the storage array that's works in conjunction with high performance FICON. So it's not a replacement for high performance FICON, but some of the IBM middleware can potentially leverage the Z Hyperlink for very low latency accesses to the data if the data resides in the cache of the storage array. We also introduced the 32 gig FICON support in support of the new IBM Z16. This can auto negotiate to 32, 16, or 8 gigabytes for Direct Connect. It's again a new 4-port module that combines FICON and Fiber Channel and SRDF in pairs that can be configured in pairs. So you could have, say, a pair of FICON as well as a pair of remote replication ports, all in the single single slick. And we continue to provide a wide range of Z Synergy. So our Z Synergy is not exclusive to IBM and IBM storage, full compatibility across the channel, then a lot of full control unit compatibility, as well as really the key copy services compatibility, flash copy in particular, and things like if you're a TPF shop, secondary STMC, secondary data mirror control. Just wanted to wrap up with a quick comparison. If you're familiar with some of the older VMAXs and PowerMaxs that are still deployed, if you looked at a 2-cabinet VMAX 40K that was 8 engines, that could be upgraded to a 2-node pair PowerMax 2500. You can see a pretty dramatic increase in the amount of storage that can be supported, up to 32 times. And a dramatically lower carbon footprint, significant increase in the FICON throughput, and a much lower power and cooling, as well as the physical footprint, 17 times lower, smaller rack units. Really, excited about the new PowerMax 2500 and 8500, the industry first compression available for all CKD data types, the 32 gig FICON, the Z Hyperlink read support, the much denser packaging and energy efficiency, and the much larger capacities that can be supported in a much denser, smaller footprint. Again, we still retain the very flexible abilities in terms of very small starting size, but going up to very large capacities, the ability to really independently scale the front end nodes with compute nodes with the media, the flexible RAID that can support up to a very single drive upgrades, the more flexible and configurable I/O modules, and ability to mix mainframe and open very flexibly, and even start an array as, say, a mainframe array and add open systems to it later, or conversely start as an open systems array and add mainframe to that array later. A lot of enhancements around security, the Cloud IQ anomaly detection, the hardware root of trust, and the multi-factor authentication in Unisphere, as well as the data rest encryption, and the introduction of the ZCID for, again, another way of detecting potentially anomalies and cybersecurity threats. Thanks for all the support and interest. Looking forward to a very exciting future with the PowerMax 2500 and 8500, and working with you as we move forward.
I don't see any questions in the chat, Bruce. So thank you very much. Nice presentation. As ever with all these presentations, I actually learned something as well. So thank you very much. If there are no questions, I'll close the recording and look forward to the next one. Cheers, Bruce.